In our previous videos, we've learned how to predict the thermodynamic favorability of a process using the Gibbs free energy equation, and we're going to apply that equation in a little different process where actually the answer depends on the temperature. So we're going to look at the freezing of water, so liquid to solid water, and we've looked up the values ahead of time for the delta H and the delta S for this process, and the values are given here. And we're going to ask ourselves, is this process thermodynamically favorable at room temperature at 25 Celsius? Now, we already know the answer to this because we know that water does not freeze at room temperature, right? We know that we need to put it in an environment where the temperature is below 0 Celsius, but we're going to work through this as an example, all right? So the delta G value is equal to the delta H minus the T delta S. That's the Gibbs free energy equation. And we're going to plug in our values that we've looked up ahead of time. So minus 6 kilojoules per mole minus the temperature. Remember to put this into Kelvin, so you've got to add 273 to your Celsius temperature here. And then we're going to multiply that by a negative 22 joules per mole Kelvin. All right. And we're going to skip a little step here, and we're going to divide this by 1,000 here to change our joules into kilojoules. All right? That way that our kilojoules are going to add to our kilojoules here. Okay, the Kelvin are going to cancel out. So simplifying, we get negative 6 kilojoules per mole. And then we're going to have 298 times 22 divided by 1,000. Now, think about your signs. You could do this in the calculator, but it's better to think about it. You have a negative times a positive times a negative. That's going to give us a positive. Two negatives make a positive. So that's going to give us a positive 6.5, call it 6 kilojoules per mole. All right? Now, we're going to add these two terms now together because we have kilojoules and kilojoules. You have a number here that is larger than this one. So when you add these two numbers together, you get a positive. And we're being a little loose with the significant digits here, but just bear with me. So we're going to get a positive 0.56 kilojoules per mole. So in other words, we have a positive delta G, and we know that a positive delta G means that the process is thermodynamically unfavorable at this temperature. And we're going to use this over and over under a number of different circumstances to prove that in some cases we have processes that are thermodynamically unfavorable at one temperature, but favorable at another. So what I'd like you to do now is to attempt to calculate this same process, but calculate the thermodynamic favorability at minus 25 Celsius and see what you get as an answer.